And welcome to expected counts. So we are again looking at the same example as in the video on the chi-square test of independence. So a study was run to determine if there is a relationship between student status and major area at a college. Researchers took a random sample of 200 students. The data is recorded below. Can we conclude at the 5% significance level that student status is associated with major area? So again, student status was full-time versus part-time, and major area was natural sciences, social sciences, and humanities. The hypotheses we came up with in the previous video were the null hypothesis is that there is no relationship between student status and major area at the college. And the alternative hypothesis is that there is a relationship between student status and major area at the college. So our job is to determine how surprising our sample is. So the first thing if the null hypothesis were true. So the first thing we need to do is figure out if the null hypothesis were true, what would we expect to happen? So, so we will base this off of the total row at the bottom. So look what we have here. We will base this off of the total row from our table. So in our sample of 200 students, we have 57 natural sciences, 77 social sciences. You like those in this basket better than that basket. And 66 humanities. So if we convert each of these into percent, we have 57 out of 200, or 0.285, or 28.5% of the sample is in the natural sciences. In our social sciences, we have 77 out of 200, or 0.385, or 38.5% are in our social sciences. And then for our humanities, we have 66 out of 200, or 0.33, or 33% were in the humanities. So essentially what we are going to do is we are going to expect, so we expect 28.5% of full-time students. What do you see? What do you see that's giving you that big smile? Are in the natural sciences. What do you want? So we will also use the row or the column total, or the total column. So we will do 28.5% of 108 full-time students. So you can either do 0.285, or we can do 28.5 out of 100, that's percent, times 108 is, and if we do this calculation, we wind up getting 30.78. So we expect to have 30.78 students in the natural sciences and full-time. Now, a slight modification of this, we actually didn't need to find the percentages. We could have just used the original fraction probability we found before. So we could have done, instead of 28.5 out of 100, we could have done the original 57 out of 200 times 108. And this will give us precisely the same thing. So we could have used the original fraction. We don't need to simplify if we don't want to. So we could have used the original fraction instead of the percent. I find the percent a little easier for students to understand sort of what's going on. So we'll do the same thing for each of our classifications. So again, we expect 38.5% of full-time students are in the social sciences. So we would do 38.5 out of 100 times 108 for our full-time. And if we do that, we wind up getting 41.58. Again, this is for full-time and social sciences. Do this again. We expect 33% of full-time students are in the humanities. So we would do 33 out of 100 for 33% of our 108 full-time students. And if we do that, we wind up getting 35.64. So this is 35.64 for full-time and humanities. And then we will do the exact same thing for the part-time students. So we expect 28.5% of part-time students are in the natural sciences. So we would do 28.5% of the 92 part-time students. Or 28.5 over 100 times 92. And if we do that, we get 26.22. So this is 26.22 full-time or part-time and natural sciences. Then we can do, we expect 38.5% of part-time students are in the social sciences. So we would do 38.5 over 100. That's our 38.5% of the 92. And we wind up getting 35.42. Where part-time, this is what we expect to be part-time and social sciences. And then we expect 33% of part-time students are in the humanities. So we would do 33 out of 100 times 92, and we wind up getting 30.36. So we have 30.36 as the expected part-time and humanities. So we can put all this information into a table. So let's do our expected counts. We will create the same table we had before. So we have our full-time, part-time, and total. Then we have our natural sciences, social sciences, humanities, and our total. So our totals will be the same. So we had 108 full-time, 92 part-time, 200 students in all. We had 57 natural sciences, 77 social sciences, and 66 humanities. Now we'll go ahead and put those numbers in. So we had 30.78 full-time and natural sciences expected. We had 41.58 for the social sciences and full-time, and 35.64 for full-time and humanities. Then we had 26.22 for part-time and natural sciences, 35.42 for part-time and social sciences, and 30.36 for part-time and humanities. So essentially, if we had a sample with 108 full-time students and 92 part-time students, and we had 57 natural sciences, 77 social sciences, and 66 humanities, if then we sort of evenly distributed those majors across our two student statuses, this is what we would expect to get. So this is kind of what we would expect on average if we took a bunch of samples with this breakdown of full-time and part-time students and natural sciences, social sciences, and humanities. So this is what we would expect if the null hypothesis were true. And so we can compare our sample results to what we would expect. So that'll be the basis behind our chi-squared test of independence. I will show you in the next video how to use Desmos to find the expected counts in one go instead of finding these by hand. And we will also use Desmos to find our chi-squared statistic and our p-value. But this is the idea behind expected counts.